So, like the title suggests, we're going to be exploiting some CNC servers today, or at least exploiting some CNC toolkits. Before I get right into that, though, these are, at least best to my knowledge, new exploits. And at the end of this, I will be releasing the Metasploit modules for these exploits. Before I get there, though, I don't want the focus to be so much about these exploits. I mean, I think they're cool, they're remote code execution, but the takeaway should be if you're a vulnerability researcher, like this field of looking at CNC servers for exploits is a ripe field. There's low-lying fruit everywhere, and I really don't feel like people are, or a lot of researchers are looking at it, or if they're looking at it, they're using them just for themselves and not really sharing. So key takeaway is this is a really interesting field, and I highly recommend anybody who's into vulnerability research to jump into it. So before I get started on the exploits, I'm going to do a little bit of background. I'm going to talk a little bit about some legal stuff, but then we'll get into the exploits. So background on me a little bit. I've been in this computer security community for over 10 years. I currently work at Symantec as a threat researcher. Before that, I worked for the DoD doing CNO, CNA. And I've done some time in the trenches as well. I was an IT administrator before that, so I know what it's like down in the field. I feel like I kind of have a good round understanding of this particular area. With all that being said, the disclaimer should come as no surprise to anybody. Everything I'm about to say up here does not represent any of the opinions, or my opinions do not represent the views of my current or former employers. Make that clear. What I'm going to discuss is probably illegal, so what you do with it is up to you. If you do cool stuff with it, I'd love to hear about it, but what you do, it's your own risk. Cool? We got that covered. All right. So, let me talk about what really led me into this field. And that's one thing that bothers me about the security community, the security defense industry, is that there's this defeatist attitude out there, right? Like, no matter how hard we try, we're going to lose. And if you went into like a basketball game with that kind of attitude, like, it's not going to work. But somehow we expect that it's okay for the security community, right? Like, I hear this sophisticated actor term passed around all the time, as if it's some kind of excuse why a company got hacked. And I don't really understand what they're trying to convey by using that term. If I try to picture like that conversation with the C-levels when you're trying to explain what just happened, sir, we've been hacked. What? How did they get in? Oh, well, they were sophisticated. Like, how do you know they were sophisticated? Well, they were wearing a monocle, so they're clearly a sophisticated actor. You know, like, what does sophisticated mean in this context? Whatever it means, I don't think it means what they're even trying to persuade it means, right? I think they're trying to persuade, or to convey, that it means that this attacker was so far beyond what we can as defenders can do that we just can't win. And so that's what I set out with this to say. I was like, well, I'm going to take a look at the tools that these sophisticated actors are using, and let's just see if they're vulnerable to attacks, if somebody was to attack them back. And so that's where I went with this. Now, Hacking Pack has been a very hot topic over the years, right? 5 years ago at Black Hat, they did an anonymous survey asking people if they've participated in hacking back in some form, and anonymously, over a third of the people surveyed admitted to it. A lot of times, when a company's hacked, they want justice, they want revenge, they want that person to pay for what they've done. So they'll go to law enforcement, and law enforcement has their hands tied, or can't do anything, or has no recourse. Sorry, we can't do anything about this. And so companies kind of feel obligated to take this on themselves. I'm just going to do it myself. Add to that this new draft bill that Senator Tom Graves out of Georgia is preparing to present. It's called the Active Cyber Defense Certainty Act, the ACDC Act. I love the acronym. But it's basically a bill that will allow those who have been hacked to be exempt from hacking laws when their aim is to attack their assailant. So this is kind of interesting idea. If this was proposed, if this draft makes it through Congress. However, generally, like, first thought, this is a very, very bad idea, right? Like, this is a game you're not going to win in the end result. As a corporation, first off, it's probably illegal. Even if that's made legal, it's still very iffy. got to take into fact all the lost productivity while you send your best guys. Rather than defending your network, you're now sending them to go attack. Not to mention the reliability. What if they attack the wrong server, or the attacks came from some other company, and then that company realized they've been attacked by you, so they hack back you, right? Like this escalation game. It's like the cyber, the War Games movie where all these guys are like hacking everybody else because one little guy. So basically, I felt like that the AI's conclusion from that movie applies very well to this. It's probably the best strategy not to play this game at all. That being said, I do see a very useful or a very niche area where hacking back it would be a good thing. And it wouldn't be a good thing in terms of revenge or taking the guys out. But you see, I work as a security researcher as my day job. So I try to track targeted attacks. I try to figure out who's behind this type of attack. And if I could figure out how the person acts that's behind the attack, what files they stole, who else they're targeting, like this kind of information, if I was to hack back and sit on their machine and observe, that kind of information is great for defenders, because then I could tell you these are the other tools they use, this is the industries they're targeting, this is the files they want. It's very useful in that sense, not so much in the sense of just striking back to get revenge. And to be honest, to be fair to the AC/DC Act, that's actually the verbiage it's trying to convey. The Act itself clearly says that you cannot attack back for the purposes of causing physical or financial injury, or to try to destroy data or machines. That you basically can't just try to break their machine, which is a good idea anyways, because if you break their machine, they're probably just going to show up somewhere else anyways. But instead, the Act says you can attack back for these purposes, is to establish attribution of the criminal activity and to monitor the behavior of an attacker. Also in the bill, it says you must share with law enforcement that you plan to do this attack and how you plan to do this, and kind of give them some details beforehand. I don't know. Anyways, I don't plan to spend forever talking about legal stuff, and I know that's not why you came here either. But I just want to, so I'll end my rants now, but I just want to kind of convey that what I'm about to discuss in the very near future could be legal. So this is maybe potential tools, like it could be legal, and this is showing it could be very plausible. So before I get into some things, I want to make sure we got terminology clear. In some circles, I've seen the client and server names for rats reversed, and that really bothers me. So the person who has the implant or the malware running is going to be the victim, or I'm going to call him the target. I'm going to try and avoid victim, and I'm going to try and avoid client, just because that one gets some people confused. And the reason I'm avoiding victim is because the attacker in the original scenario is going to be our victim. So attacker, victim, probably terms I'm going to try to stay away from. And I'm introducing a new one. That is the person who's attacking back, I will call the retaliator. I really like that term because the dictionary definition is one who returns assault in kind. We're going to be hitting them with our own medicine here, so I felt like retaliator is the right name for this. A little while ago, one of my colleagues, he took all the recent APT reports, the sophisticated actor reports, and he kind of summed it up into most popular tools, most referenced tools out of those papers, and he posted this on a Twitter feed. And I saw this list, and I was like, that is my shopping list. I'm going to start at the top and just start working my way down, finding an exploit in each. And so if you'll notice, the top one is poison ivy. And if any of you recall or are aware, there is already an exploit out there for poison ivy. The two individuals at the bottom of this slide developed that. I'm not going to try to pronounce their names because I would not do well. But they developed a remote code execution vulnerability against the poison ivy C2 server. And interesting enough, after the Mandiant APT1 report, the malware LU guys noticed that APT1 group was using the poison ivy server, so they used this exploit to hack back into their infrastructure. But they documented the whole thing and published it. And this is one of the rare cases where we have of somebody doing a hack back for attribution or for monitoring purposes, and it really shows how successful it can be. This picture, the farthest picture on the right, is a diagram that they show that they were giving, trying to show us how they built the attackers had their infrastructure set up, how they had some VMs and some proxies to try to protect things. They also were able to pull back some additional tools the attackers were using, and they exposed them publicly. And it's very insightful paper. They called it the APT1 Technical Backstage. It came out, I believe, in 2013. It's been around for a little while now. It's a really good read, but I think it's one of the rare cases where we can see how useful this type of activity is. Another one on that list was Dark Comment. It also has public exploits. This is a blind file retrieval by these individuals. I don't have any, or I didn't find any public documentation of anybody using this publicly. But I figured I'd mention it just for completeness. And with that, we're going to start playing with our new stuff. I'm going to start, so I know I told you I started on the list and worked my way down, but I'm going to work now when I present them from bottom up because I feel like it's least interesting to most interesting in that order. So fourth on the list, or the last one I looked at, is called Extreme Rat. Who's familiar with Extreme Rat? Has seen it, ran into it? Okay. Yeah, it's not the most common APT toolkit. In fact, I wouldn't even really consider it an APT toolkit thing. It actually was a commercial product. This image here is of the CNC server component. I've got one victim, and that drop-down list lists some of the features that the attacker can do to that victim. This tool was sold out there on the markets, and at some point the source code was leaked, and the author just kind of quit selling it. So it's still out there. The source code's leaked out there, and it's still kind of around. There's a lot of variants that base themselves now off that source code. A lot of the features are very script kiddie-ish. Like you can tell it targets script kiddie guys, like wannabe hackers. In fact, one of the features it has is you can play flash games in the app while you're waiting for somebody to click on your malware. It's like, if you're not very good, at least you can, play some Candy Crush or Jewel Quest game while you wait because your phishing email sucks. But despite this, it's actually been cited in numerous articles as part of targeted attacks. So even sophisticated actors like using this tool. It's been cited in attacks against the Israeli government, in conflicts in Syria and the Gaza Strip. So kind of hotbed areas do get hit with this guy. And the easiest way to identify this inside a network is its C2 communications. Most of the targets we've seen, it either calls home one of two ways, raw TCP or a fake HTTP message. The raw TCP is always starts out with the string my version pipe and then the version 3.6, 3.7, 3.8. Those are the most common. And the C2 server always responds with the character X followed by line feed carriage return. That's like super signatureable, right? Like snort signatures already exist and such. It's very easy to watch for that. Alternatively, if it does the HTTP requests, they'll always take the form of a GET request / some number.functions. And that some number is the password that the script kiddie uses when they first run the app. And the app makes sure that the password is up to 10 characters, can't be longer than 10, and they all have to be numeric. So looking for any URL request for 0 to 9 or 1 to 10 character numbers .functions is going to hit on this and most exclusively hit on this. I really doubt there's legitimate traffic going to that URL pattern. And so this guy, like I said, there's source code out there. It was in Delphi, so I really don't like to read Delphi. So I just kind of started reviewing some of the basic C2 comms. I had myself a victim, and I would do all the maneuvers to the victim and watch the C2 traffic go back and forth. And one thing I noticed that struck my eye was how the C2 server pushes a file down to its victim. And what it'll do is it'll send a message to the target and say, hey, get ready to receive my file tool/bad.exe and save it to your C drive temp as calc.exe. And then the target will respond back, okay, I'm ready to receive your tool named tool.bad.exe. And then the data is passed to the victim. And it made me think about this. Why does the victim need to know at all where that file is stored on the server's hard drive? And I was like, well, maybe it does that because the server doesn't want to keep state. It doesn't want to keep in its memory the fact that it made this request, because all the data it really needs is in the response from the victim. So turns out that the first packet is even necessary. As a victim, I can go to the Extreme server and say, hey, I'm ready to receive your file, C drive / whatever, and if that file exists, it gladly hands it to me. Yeah, it's kind of a blanket basic mistake. But what can I do with this? Unfortunately, I can't do a directory listing, so I have to know the file exists. I can do like brute force all the files, but there's better ideas than that. I didn't make these ideas up. This is from the link at the bottom. Blind file retrieval is often a case pen testers get in, so they've thought about this a bit. And these are some things that they suggest pulling back. The first one is the WinINI file, because on any version of Windows, that file exists. So it's like a sanity check. If you can pull that file back, we're good. More so, if you can pull that file back, you might be able to tell what version of Windows they have. If you know what version of Windows they have, you know the path to the event logs. So we can start pulling event logs. In the event logs, there's usually a lot of good data in there. If applications crash, you know the path to the application. If a program a user runs crashes, you may know the username. So now if we know the username, we can start pulling files out of the user's home subdirectory, like the desktop.ini, because that will tell us all the folders that the person has or files on their desktop. And we can keep kind of iterating through their network or their computer, finding out things like that. If the attacker is running this program as administrator, then we can always pull the backup of the SAM database, and then we get their username and passwords. Maybe we can pull the backup of the registry, because the registry is going to have a whole lot of great information and more things that we can pull from their machine. These are just some ideas of the things you can do with that bug. And with that, I'm going to move on to the next one. This one, plugx, core plug, or destory. It's called destory because somebody misspelled destroy in the source code. But this is a more common tool. It's been around since 2008. The back window is the main tool, you see the CNC component, and the front window is the pop-up that you can get per victim, and each tab is a set of features you can do to a victim. This one is a little bit more, I don't know, I'll say professional, but it's a little bit more tailored. I can tell the source code is passed around between groups. I see different variants of this out there, but the biggest changes I see in the variants is just the GUI and not so much the functions underneath. It's like every new hacker likes to throw their own GUI on there and put their own QQID on there and claim that they wrote this, but it's all the same stuff under the hood. Some of the cool features I've noticed, though, it has features for interacting with SQL databases, for directly editing the registry, for capturing packets, or doing network monitoring. So it's a pretty feature-rich rat, and it's been cited in a lot of targeted attacks. Most recently was one in February, the one that says, oops, they did it again. Yeah, this tool has been around for quite some time. I can start naming the places it's been used against: Afghanistan, in India, Mongolia, Kazakhstan, Japan, Taiwan, Korea, Tibetan organizations, and it just goes and goes and goes. This thing's been around for quite some time. This one I could not get a hold of the source code for, so I was going to rely on dynamic analysis and fuzzing. And so I was building a fuzzer to try to fuzz the protocol, how the victim talks to the C2 server. And when I got my fuzzer up and running, this thing would fall over left and right. And I just had a hard enough time keeping the program running and getting, the list of bugs and the vulnerabilities and potential crashes that could be turned into exploits was so high that I kind of got overwhelmed with the fuzzing and decided just to go look at static analysis. And so I was looking at the code, and one of the first areas I was looking at was when you receive a message from the victim, how does it handle it? And they handle it all right. When it receives a message from the victim, each message, or packet as they call it, each message has a little header that's XOR encoded with their own little made-up XOR scheme. And so they decode the message header, and then they look that the message is small enough to fit on the stack buffer that they prepared for, right? That's a good security check, that F000. So it has to be smaller than 61K, which is a rather large message. If it doesn't fit, then it shows a pop-up message. However, this code to check that the message will fit on the stack is down here in this decode packet function. You can't see my mouse. It's on line 36. But you'll see up on line 29, it copies the packet to the stack and then later decides maybe I should have checked if it was going to fit. And so because it's on the stack, right, we can overwrite the return address. But the return address isn't hit until this function leaves, which means if I overflow this buffer, I'm going to get control as soon as this function finishes, but before the function finishes, it pops up this pop-up message that very, very clearly tells the attacker what just happened, right? PE decode packet. Come on, don't you understand? You just got exploited, buddy. And the funny thing is no matter what they do, if they click the X or they click the OK, it doesn't matter because I get code flow either way. They just have to acknowledge this in some sort of way. Now that's not cool, I agree. But turns out that this message is like the de facto error. In fact, if you nmap a plugx server, it will show this message. It just doesn't, this is like, I don't know what happened message is really what this is trying to say. And so for this one, I have a demo real quick. I see my mouse. The right half of the screen is going to represent the attacker's computer, and the left half of the screen represents the retaliator's computer. I'm going to start up the plugx server, and then I will just point my Metasploit script at it. So we'll start up my plugx Metasploit script. Because it's a VM, I already know the IP address, so I'm just going to type in that IP address and set the attack at that. We'll talk more about how to find out who to target later. Now, I'm going to pause this real quick and have an aside. One of those papers or the articles I mentioned was a talk from Black Hat known as I Know You Want to Unplug Me, where they talked about plugx rat and talked about the, that's not what I wanted to do. All right, I'll just start this up while I talk some more. And they talked about the different variants they observed. And in their terms, they observed 3 types. Well, basically, they used 3 different XOR schemes. They changed. And so I've written my module to be able to handle each type, but I can't know ahead of time what type you're targeting. So basically, you run the check command, and if it's not that right type, we'll change the type and run the check command again until you validate that you've got the right type. So you see plugx type 1 old, and type 2. So I run the check command. The check command says, yep, you're good. So we'll hit exploit. It'll pass the attack against the server. There you see the pop-up message over there. The attacker's like, what the heck? It's X, or the victim now. And you see my meterpreter session spinning up. I'm going to do a quick sysinfo. Yeah, it'll spawn a shell. And I think notepad, popping notepad. Visually, there it is. All right, on to the last one. Ghost Rat. How many of you have seen or heard of Ghost Rat before? Yeah, I like that hand. So that's exactly what this guy is. Like, it is the one that's been around forever. At least 10 years. It was really originally written by a group that called themselves C. Rufus Security Team, also known as the Red Wolf Security Team. It's most often cited in attacks that come out of Asia region. This image is of the C2 toolkit, and again, you right-click on a victim, and there's your feature set. Kind of typical feature set, nothing fancy. This is almost, in my opinion, the measuring stick for rats is Ghost Rat. Like, they should at least be able to do what it can do. And Ghost Rat, it has been cited in so many articles. These are just a few that I could fit on the screen there. Most recently is the one down in the bottom left, which was just this year. Ghost Rat was being spread this Eternal Blue. So it's still very popular. I think the oldest one on there, I can't find the dates, but it's been around for at least 10 years. And again, it is very easy to identify based on its PCAP, based on its traffic. It has a signature 5-byte ghost pattern, the first 5 characters in each packet message from the victim to the C2 server or from the C2 server back to the victim. Now, the source code for Ghost Rat has been leaked online, and so many people or many attackers know that ghost is like a big red flag, so they'll try to change it to something else. That second image is from a talk Snora gave where these are different 5-byte characters he's seen that change to. They usually always only change the 5 bytes just because that's easiest, and if you change it to something longer, it requires a lot of other changes in the code. But even still, it's very easy to identify this no matter what those 5 bytes are, because it's always followed by another pattern of 2 integers and then a compressed buffer. So it's still very easy to identify no matter what the 5-byte character is. And like Extreme Rat, it had a very similar logic bug. But this one is the other way around. When it's requesting a file from its victim, it will tell the victim, hey, give me your local file, document user file.doc, so I can save it to this path. I'm like, well, that's very nice. Here's the data. You can save it to that path. Oh, by the way, I also have this second file that I'd like you to save to your startup folder. And sure enough, if you know the path to their startup folder, it'll put it right there. Now, the startup file folder changes in different versions of Windows, so that's not the most reliable way. If you can nmap their machine and tell what version of Windows they have, then boom, you can do this. But I had to find a better way. And sure enough, GhostRat has another very handy for me. It is vulnerable to a DLL sideload attack, meaning if I just drop a file named OLE-DLG, a dynamic library, right in that same folder, the local folder, then it will try to load that file whenever Ghost starts up. And it's looking for only one function in that DLL, and that is OLE UI busy. It's basically a function that can ask, is the UI busy? And it expects to hear a 1 as a return from that. I don't know. A 1 means not busy. It's really confusing. But anyways, all you have to do is you make your malware into a DLL, have it export this one function that just returns 1 all the time, and Ghost will be none the wiser. It doesn't break anything doing that. And the next time Ghost starts up, it'll load your malware, or every time Ghost starts up, it'll load your malware. So that was cool, but it requires dropping something to disk, and I wasn't done picking on Ghost yet. Because Ghost, like I said, had the source code, so I started looking at the source code, and right away this one stood out to me. I found it in like an hour or two. It's basically, this is in the handling of the drive list as given from a victim. So when the victim says, oh, I have drives C, D, and E, it's in a buffer, right? And you'll notice on that second line, it just assumes that the list, it takes the length as given from the victim rather than assuming the length is less than its buffer size. So if I pass out a list of drives that are longer than the usual max of 26, then I can overflow a buffer within this particular C class. So the buffer I'm overflowing is in line 45, the remote drive list, which means I can overwrite any one of those objects below inside the class. A lot of those objects below are other C classes. So I can overwrite the pointer to those C classes. Then when the actual code flow tries to call a function in one of those C classes, it's going to end up calling a pointer that I control that needs to point to another pointer that points to my code flow. So I basically have to set up a pointer to a function that I want to run, which is kind of messy. Pointer to pointers aren't really the funnest things to use for exploitation, but they work. If I had an information disclosure, or if that would give me the layout of memory, that would make pointer-to-pointer code flow pretty easy. But I'm lazy. I didn't spend time looking for that. And I knew that I could just do a heap spray and have a really good chance of landing in my own heap. So that's what I did instead. I did the lazy man's approach. After I released these modules, I would love to see somebody maybe who's more willing to do work than I am make the exploit a little bit cleaner that way. But nonetheless, that's what I did. DEP would break this approach, but DEP seems to break the executable. Whenever I'd run GhostRat on a machine that forced DEP's execution, or if I opted in, Ghost would just crash. It wouldn't even run. So didn't need to really worry about DEP. That could probably be changed, but it wasn't a problem for me. Now, before I go on to show that demo there, or the video, I wanted to talk about something that another researcher called Kevin the Hermit has done, or Kev the Hermit. He has written a number of decoders. So if you're given a piece of malware from any one of these families, with the exception of PlugX, you can run the script on it, and it'll extract from that piece of malware the C2 address that it was meant to call home to, along with some other configuration data. So if you're the victim of one of these attacks and you find this file, you can pass it to a script, find the address of the C2 server, and then we can use Metasploit to attack that C2 server. But if you're too impatient to wait for yourself to be attacked, you could always search VirusTotal for these files, or just do a quick search for ghost rat samples and find quite a few. Some may be old, some might not. Or Shodan was very nice recently and added a malware hunter feature that looks for C2 servers, and one of the C2 servers that they look for is Ghost. So we could just do a quick shopping list off of Shodan and have some fun. Again, this demo is same setup: attacker or adversary on the right, retaliator on the left. And this one I'm going to do just slightly different in that I'm going to build a malware sample from the GhostRat tool, and I'm going to pass that malware sample to the retaliator, and then using that script that Kev the Hermit wrote, extract the C2 info, and then use that to attack back. So I made the sample, and then I wasn't thinking, and I closed GhostRat. Oops, I pressed a button. All right, sorry to make you watch it again. Yeah, so I make the sample, and then I'm going to just drag it out of the VM. In a usual case, right, it'll arrive via an email or a watery hole attack, but I'm not going to go through all that. We all know how those work. So I just drag the file out of the VM, and then I'm going to run the rat decoder script on that sample. If I can type fast. There it is. And you can see there the C2 address and the port that it's looking to go to. I realized my mistake, started back up the Ghost Rat server. And on the left, I'm starting up Metasploit, and then I'm going to load my module, set the remote address to the remote address that we extracted from the malware itself. Just quick info showing what's available. I don't want to click pause. I'll try. No, I won't. I don't dare. So if you find a C2 server that doesn't use the ghost magic, you can just set the magic to match whatever the server is. And I throw my exploit. Now, it's going to take just a minute because I'm spraying the heap, so I'm sending a lot of data over. But there we see the stage, interpreter session starting. I'm going to do the same set of commands. I'm going to, as soon as it comes back, do the sysinfo, spawn a shell, and this time I think I'll pop calc just to be different. Yes, there she is. On a Windows 10 machine. So that begs the question, then what? What do we do now? And to be honest, I'm not quite sure. This is an area that hasn't really been discussed, at least publicly. But here's what I would suggest maybe. And maybe these are bad ideas. I'm not sure. Somebody else could decide. I don't know. But one of the first things I would be interested in doing would be netstat. Because netstat would tell you all other connections to that box. If there are other victims beside yourself, they would show up in this netstat listing. So you can find out who else was targeted. Every one of these C2 tools has a folder for the files that have been downloaded from victims. And I would look at that. I would see what files had they pulled from other victims. What were they interested in? What did they pull from you? Also, maybe you would want to install some sort of persistence so you can stick around longer. Maybe you'd want to install a keylogger to see what else they're up to. If they're dumb enough to log into Facebook from their ops machine. Who knows? A lot of different things that are optional to do. But whatever you do, I highly suggest you don't go the revenge route, but you sit quiet and you listen. Because I feel like that's where the most value in these are, right? The more you observe about your adversary, the more likely you are to win in the long run. So with that, that's about all I had. I appreciate you guys coming and spending the time here. This URL, and thank you. Thank you. That URL is where I currently have a fork of the Metasploit until I can get them pulled up into the main branch. And it depends on how well I am at meeting all the check marks before that'll happen. So you can grab it there until they're released. Again, thanks anyways.